Hi, I'm Miss Nickerson.
And I'm Mr. Radford.
Welcome to the Viking Science Academy. Last time we learned about how electrons fit around atoms in electron shells. We learned that each shell can hold a certain number of electrons. Well, when those shells do not have all the electrons that they want, those atoms are not happy.
They are not. For whatever reason, atoms want to have their outer shell full of electrons.
And they'll do a lot of things to get it full.
Yeah.
So what we're going to go over today is bonding. We need to know how many electrons an atom would like to gain if we're going to talk about bonding. So you need to know how many it needs to fill its outer shell. That's pretty simple math, but you need to make sure you know how to do that on any element. So we're not talking about James Bond, although that would be a fun discussion too. We're talking about chemical bonds. And the first type of chemical bond we need to know is an ionic bond. And then the other type is a covalent bond. There's metallic bonds, other kinds, but these are the two we're going to focus on. It's ionic bonding and covalent bonding. So let's start with an ionic bond. What's an ionic bond?
Ionic bond is basically a bond between two that are electrically charged differently. So I call it there's a theft that has been taken.
Exactly, a theft. So we get one atom stealing the electrons of another atom, but they both leave a little bit happier.
They do,
sometimes.
yeah.
Okay. So there's a couple examples of chemicals that are made from ionic bonds: sodium chloride, calcium chloride. It produces different states, and usually they have a high melting point. So we can see here the sodium atom is giving the chlorine its extra atom and extra electron in its outer shell, and now they're both happy because chlorine has 8, sodium got rid of that extra one. In good shape.
They're good to go. Yeah.
Okay.
There's another visualization of it happening.
You can see how sodium is now left with 8 in its outermost ring. Chlorine's got 8 in its outermost ring. It's in good shape. So ionic bonds, giving up electrons. Then there's covalent bonds. What's a covalent bond?
Okay, so covalent bond is kind of when you work cooperatively with someone. You're both you're working with each other, and so it's a sharing.
Okay, so these are usually non-metallic elements that do this. We've got oxygen gas, carbon dioxide, water. They're sharing electrons. So here we have ionic bonds, which was one dog stealing the bone for the other. But covalent bonds, they share electrons. And so they both get to count that electron in their outermost ring and make it work together.
And the covalent bonds tend to be stronger because of that. They're both kind of hanging on to those electrons together.
Okay. So now that you know how bonds work, make sure you could tell us the difference between a covalent bond and an ionic bond. Thanks for joining us for the Viking Science Academy.
Okay.